Good morning, students. Today we start chapter number 2, Units and Measurement, in which we discussed few topics. So let's start with the first topic, System of Units. System of units. What do you mean by system of units? A system of units is a collection of units in which certain units are chosen as fundamental and all others are derived from them. This system is also called an absolute system of units, in which we discussed few systems, which are first CGS system, second MKS system, third FPS system, and fourth one is SI system. So let's start with the first system of units, CGS system of units. It is also called a Gaussian system. In this system, unit of length is centimeter, unit of mass is gram, unit of time is second. The full form of this system is centimeter, gram, second system of units. The second one is MKS system of units, in which unit of length is meter, unit of mass is kilogram, unit of time is second. The full form of this system is meter, kilogram, second system of units. Third system is FPS system of units. The full form of this system is foot, pound, second system. In this system, unit of length is used as foot, unit of mass is pound, and unit of time is again second. And the last one and the most important system of unit is SI system of units. In this system, unit of length is meter, unit of mass is kilogram, unit of time is second. Now, the full form of SI system is Standard International, the system of units. Standard International, that means the unit which is used in this system is internationally accepted. Sometimes we are using unit of length is centimeter, unit of length is meter, sometimes we are using kilometer. So there are lots of confusions, that one student is using centimeter, another using foot, another using meter. So we are using SI system. So all students are using the same unit. Okay? Now, our next is physical quantities. The quantities in terms of which the laws of physics can be expressed are called physical quantities. Physical quantities are of two types. One is fundamental quantities. Fundamental quantities are the quantities which are completely independent and cannot be converted into each other. These are seven in numbers: mass, length, time, temperature, electric current, luminous intensity, and amount of substance. Let's see with one example. We cannot measure our weight in meter. Are we measure? No. That's right. Time cannot be measured in kilogram. With these two examples, it is clear that mass is not depend on time or any other physical quantity. In the similar way, time does not depend on other quantities. Second, derived quantities. The quantities which can be obtained with the help of fundamental quantities are called derived quantities. For example, speed. What is the formula of speed? The general formula of speed is distance by time. Yes, distance is measured in meter, kilometer, miles. Each and everything which is measured in meter, centimeter, millimeter, kilometer are termed as length. So the speed is depend on two fundamental quantities which are length and time. So speed is derived quantities because it is depend on fundamental quantities. And the units of fundamental quantities are fundamental units. And the units of derived quantities are derived units. Advantages of SI system. What are the advantages of SI system? First, it is a rational system. Rational. That means it uses only one unit for one physical quantity. For example, in SI system, joule is the unit of all kinds of energy as mechanical energy, electrical energy, heat energy, etc. While in MKS system of units, these energies are joule, calorie, and watt hour respectively. Units of temperature in MKS system are Celsius, Fahrenheit, Kelvin, while in SI system it is only Kelvin. So it is clear that what do you mean by rational system? Second is it is a coherent system. It means all derived units can be obtained by multiplying or dividing the fundamental units without introducing any numerical factor. Third, in electricity, SI units are same as practical units. Units for current, potential, resistance, inductance, etc. are ampere, volt, ohm, Henry, etc. Fourth one, it is an international system. This advantages is most important. It is an international system. All of its units are internationally accepted all over the world. Now, few definitions are here. Dimensional constants. See, dimensional constants. The physical quantities which have dimensions and have a fixed value are called dimensional constants. Example, gravitational constant. See, this is a constant, but it has a fixed value. So, gravitational constant is dimensional constants. Planck's constant, universal gas constant, velocity of light in vacuum, these all are having a fixed value and dimensions. Okay. Next is dimensionless quantities. Dimensionless quantities are those which do not have dimensions but have a fixed value. See, there are so many physical quantities are there which is dimensionless, but still their fixed values are there. Dimensionless quantities without units means we are taking that few quantities which does not contain any units, like pure number, pi, sin theta, cos theta, tan theta, etc. These are having a fixed value but no dimensions. Dimensionless quantities with units. See, in that we take some physical quantities which are dimensionless but still having their units. Angular displacement. Angular displacement has no dimension but still a unit is represented angular displacement which is radian. Joule's constant having a unit joule per calorie, etc. Dimensional variables. Dimensional variables are those physical quantities which have dimensions and do not have a fixed value. Example, velocity, acceleration, force, work, power, etc. Dimensionless variables. Dimensionless variables are those physical quantities which do not have dimensions and do not have a fixed value. For example, specific gravity, refractive index, the coefficient of friction, Poisson's ratio, etc. Now, our next is dimensions and dimensional formula. So, in which we discuss that what do you mean by dimensions? The power to which fundamental units are raised to represent a derived quantity are called dimensions. Generally, dimensions are represented by mass, length, time, and current. For example, what is the dimension of speed? So here we are using a general formula of speed, which is distance by time. In earlier we are already discussed that in distance we are taking unit of length, and in time we are taking unit of time. Unit of length, distance. Distance is measured in meter, and each term which is used in meter, kilometer, millimeter are termed as length. So distance in length and time t, L upon t. So take t in a numerator please. So here L t minus 1. So the dimensions of speed is m raised to power 0, L raised to power 1, t raised to power minus 1. It represents that dimensions of speed is in mass is 0, in length is plus 1, and in time it is minus 1. So dimensions of speed is m raised to power 0, L raised to power 1, t raised to power minus 1. So that the power to which fundamental units are raised to represent a derived quantity are called dimensions. So this power which is raised to the fundamental quantity, these powers is said to be the dimensions. Dimensional formula. Combination of fundamental units to represent a derived units is called dimensional formula or dimensional equation. For example, m0 l1 t minus 1 represent dimensional formula of speed. We are understanding that how the dimensional formula is made, how to write the dimensional formula, how to form a dimensional formula. So we are taking some examples. First one is density. The general formula of density is mass by volume. Mass by volume. Suppose that we are having a rectangular. So the volume of rectangle is, or cuboid is, length into breadth into height. We are already understand that length is measured as centimeter or meter. Breadth is also measured in centimeter or meter. Height is also measured in centimeter or meter. So we can say that length into breadth into height is L raised to power 3. So mass is termed as m and volume is L raised to power 3. Now L raised to power 3 termed as a numerator, so it becomes ml minus 3. So the dimensional formula of density is m1 L minus 3 t raised to power 0, because in density time is not there. So we can say the dimension of time is raised to power 0. Now second is momentum. The general formula of momentum is mass into velocity. Mass into velocity. And the general formula of velocity is displacement upon time. Now mass termed as m, displacement measured in centimeter meter, so it is termed as length, and time t. So m into L upon t. So in the next step we can say that m L t minus 1. So the dimensional formula of momentum is m raised to power 1 L raised to power 1 t raised to power minus 1. Now next, force. The general formula of force that we have studied in 9th standard, which is mass into acceleration. Mass into acceleration. Now the general formula of acceleration is change in velocity upon time. So mass m, change in velocity upon time. Mass, now change in velocity is what? Displacement upon time. So our formula becomes mass into displacement upon time into time. So mass m, displacement as length, and time into time means t raised to power 2. Now our formula becomes m raised to power 1 L raised to power 1 t raised to power minus 2. Now, our next topic is dimensional analysis. Dimensional analysis, in which today we just discussed about to check the correction of an equation. How to check an equation, that whether it is correct or incorrect? So let's see. For example, we have to check correction of equation h equal half gt, where h equal height, g equal acceleration due to gravity, and t equal time. So let's start this with the solution. Half is what? Dimensionless quantity. Dimensionless quantity, that means half does not having any dimensions. So we are just removing half, substituting dimensions on both sides, means the physical quantity which does not contain any dimensions, we are simply remove, and we are putting the dimensions of the physical quantities. Now height is measured in centimeter, meter, kilometer. So it is, the dimensional formula of height is length. So m raised to power 0, L raised to power 1, t raised to power 0. So that is the dimensional formula of height. Now acceleration due to gravity. We have already discussed in the previous slide that acceleration. So acceleration of the car, acceleration of the bike are simply acceleration or acceleration due to gravity. All are having the same dimensional formula, which is m raised to power 0, L raised to power 1, t raised to power minus 2. And the time m raised to power 0, L raised to power 0, t raised to power 1. So see in the RHS side, both the dimensional formula are in the multiple form. So we know that when base are same, the powers are added. So see m raised to power 0 into, again in the next dimensional formula, m raised to power 0. So m raised to power 0. In the next, L raised to power 1 and L raised to power 0. So 1 plus 0 is again 1. T raised to power minus 2 and T raised to power 1. So minus 2 plus 1 minus 1. As a dimension of T are not same. See, in these two formulas, m raised to power 0, m raised to power 0, that's okay. L raised to power 1, L raised to power 1, that's okay. T raised to power 0 and T raised to power minus 1. So with the help of these, we can say that as a dimension of T are not same, hence equation is not correct. Second, we have to check correction of equation S equal ut plus half gt square, or S is equals to ut plus half at square, that is the equation of motion, where S equal distance, u equal initial velocity, t equal time, and g is acceleration due to gravity. So let's start with the solution. Again, half is what? Dimensionless quantity. So we are simply avoid this half and substituting dimensions of both sides. First we are putting the dimension of S, distance. Distance is termed as length only. So m raised to power 0, L raised to power 1, T raised to power 0 equal. Now ut, the dimensional formula of velocity is m raised to power 0, L raised to power 1, T raised to power minus 1 into the dimensions of time is m raised to power 0, L raised to power 0, T raised to power 1 plus the dimension of g is m raised to power 0, L raised to power 1, T raised to power minus 2 and T square. So the dimension of T is m raised to power 0, L raised to power 0, T raised to power 1, but they are T square, so we can simply squaring the dimension of T. Now see these two are simply multiplying these two physical dimensions. So when base are same, powers are add. So m raised to power 0 and m raised to power 0. So 0 plus 0, 0. Again m raised to power 0. L raised to power 1 and L raised to power 0. So 1 plus 0, 1. T raised to power minus 1 and T raised to power 1. So T raised to power 0. In the second, m raised to power 0, L raised to power 1, T raised to power minus 2. And see, in that this dimension having whole square, so we can just squaring the dimensions. M raised to power 0, L raised to power 0, and see T raised to power 1 whole raised to power 2. So T raised to power 2. Now see these two. Again we are using the same. When base are same, then powers are added. M raised to power 0 plus 0, 0. L raised to power 1 plus 0, 1. T raised to power minus 2 plus 2, 0. Now add these two. These two are same. So simple addition is what? It is 2 times. So m raised to power 0, L raised to power 1, T raised to power 0 is equals to 2 times of m raised to power 0, L raised to power 1, T raised to power 0. Again 2 is dimensionless quantity, so we are simple removing it and see that the dimensions are same, so you can say that the equation is correct.